Very warm welcome to all. Last day we have discussed about photoelectric effect which light waves show, or we can say light as electromagnetic radiation show. So we have discussed the experimental setup of photoelectric effect and discussed its outcomes, or we can say results. These results of photoelectric effect are nothing but the laws of photoelectric effect. So today we will try to understand, or we will try to explain these laws of photoelectric effect first on the basis of wave theory of light and then on the basis of Einstein's theory of light. So we already know that what wave theory of light says, proposed by Huygens, that light travels in the form of the wave, due to which it shows the phenomena just like interference, diffraction, polarization. So let us take the very first thing, which wave theory of light says about photoelectric effect or its laws. It says that light incident on a metal surface, it spreads evenly all over the surface. Whenever light is incident on a surface, it spreads all over the surface of that metal on which it is incident. And the energy of this incident radiation, it is shared by all the electrons present on the metal surface. So therefore each and every electron gets a very small amount of energy. So for an electron to come out from the metal surface to cause the photoelectric emission, it takes some time for the electron to absorb the sufficient amount of energy from the radiation which is incident. So therefore there exists some time lag between the incident radiation and the we can say emission of electrons. So experimentally there is no time lag, there is a spontaneous emission of electrons, but according to wave theory it may take some time, or it takes some time for the electrons to be emitted out in photoelectric emission. So in that case wave theory fails to counter the spontaneous emission of electrons. Second thing what wave theory says is that emission takes place for the radiations of all frequencies, be it small or high. That means for all kind of radiations of all frequencies, the emission can take place. However, it may take time to cause the emission. So therefore, wave theory of light says that there exists no minimum frequency which must be obeyed, right? So it again violates the existence of the threshold frequency, or we can say it cannot explain the existence of threshold frequency, as we have already discussed. Here in this graph you can see that there is some minimum frequency below which there is no emission, right? So this we have discussed earlier. So again the second thing is also remain unexplained on the basis of wave theory of light. Third point which wave theory of light says is that kinetic energy of the photoelectrons varies directly with the intensity of the radiations or the light which is incident. But experimentally we have already come to know that kinetic energy is found to increase with the frequency, right? As the incident of higher and higher frequency is incident, more and more stopping potential is required to stop the electrons emitted. That simply means that higher the stopping potential means higher the kinetic energy, right? And we know that the stopping potential is higher for the higher frequency radiations. That means the kinetic energy depends upon the frequency of the incident radiation and is independent of the intensity of the radiation. So here again wave theory of light fails to explain the reason for this experimentally verified outcome, or we can say law of photoelectric emission. Let us try to go for a different view. So a different view is proposed by the Einstein called as a particle theory of light. And these particles of the light or packets of the light are called as the we can say photons. These are given the name photons. So what is a photon? It is the packet or bundle of energy that is called as photon. So whatever the light is, its small particles are called as photons, and photons are nothing but the small packets of energy carried by that particular radiation. So the energy of each and every photon is given by this energy is given by E is equal to h nu, where h is the Planck's constant and nu is the frequency of the incident light. And because frequency can also be written as c upon lambda, therefore energy can also be written as hc upon lambda. So here, according to Einstein, the light travels in the form of small packets of energy, which we call as photon, right? These photons are also called as the particles of the energy. So according to Einstein, light in place of wave nature exists, or we can say possess a particle nature of the light, and these particles of the light are called as the photons. So photons are nothing but the small packets or bundle of the energy, and the energy carried by each and every photon of a radiation is this, E is equal to h nu. We already know that c is nothing but the speed of the light in the vacuum. So with this, the Einstein proposed the particle nature of the light. He explained the behavior of the photon in terms of these points. Very first is that a photon travels at a speed of light c in the vacuum. C means 3 into 10 to the power minus 8 meter per second. So each and every photon of the light, it has the speed which is given by this. Another thing about photons is that it has zero rest mass. That means at rest we have no photon. Means the photon does not exist at rest. So whenever there is a light, only then there is a photon, because whenever there is light, it keeps on traveling. So photon exists while it travels. It has no rest mass, or we can say it has no rest existence. Third thing is that kinetic mass of the photon, kinetic mass, because if it exists, then it exists only in the light, in the form of the light, which keeps on traveling. So therefore its mass is called as the kinetic mass. And according to Einstein's mass energy equivalence or mass energy relationship, each and everything in this universe exists in the form of energy and the mass or material particle, which is related by this identity, or we can say formula. So the mass corresponding to this much speed of the light is given by m is equal to E upon c square, where E is the energy carried by that photon. So this is the, we can say, mass of the photon, or we can say kinetic mass of the photon. Again, we can substitute a value of E from here and put the mass, kinetic mass of the photon in this way, h upon c lambda. Next property exhibited by the photon is that the momentum of a photon is given by P is equal to E upon c. Again, we can substitute the value of E and put the momentum of a photon in this way, h upon lambda. Photons travel in a straight line. The energy of a photon depends upon the frequency of the photon. Of course, if energy is given by h nu, that means higher frequency radiation will carry the photons of higher energy. So the energy of the photon does not change when the photons travel from one medium to another. Okay. Another point is that for a particular radiation, the energy possessed by all of its photons is same. For one particular radiation, all of its photons possess the same amount of energy given by E is equal to h nu. Okay, another thing is that wavelength of the photon changes in different media, which we already know. So the velocity of a photon is different in different media. Photons are electrically neutral. Because they are electrically neutral, so they are not deflected by magnetic and electric fields. Photons may show diffraction under given conditions, as we have discussed in Huygens theory. During collision between a photon and a material particle, the total energy and momentum remains constant. So these are the few things which must be remembered regarding the photon theory of the light proposed by the Einstein. Now, on the basis of this particle theory or photon theory of the light, the Einstein explained the laws of photoelectric emission, and for this he gave an equation called as photoelectric equation. So what he says, or what this theory says, when a photon of energy h nu, as we have discussed, falls on a metal surface, so its radiation is incident, and each and every photon of the incident radiation is having the energy h nu. So when this radiation is incident on the metal surface, the energy of photon is absorbed by the electron, right? So energy of one photon is absorbed by the one electron alone. All of the energy possessed by one photon, right? So it is transferred to the electron, one electron only. And it is not like that energy of a photon is shared by number of electrons. It is not like that. One photon is completely absorbed by one electron, or in other way we can say that energy of one photon is completely taken by one electron. And this energy, when electron takes this energy, it uses this energy in two ways. Some part of it is used to overcome the surface barrier, or we also call it work function. And we already know what is a work function. It is the minimum amount of energy which is required to take the electron out from the metal surface. So some part of the energy absorbed by the electron, it is used to overcome this, we can say, energy or barrier. And remaining part of the energy, it is used in giving the velocity to the emitted photoelectron. Remaining energy of the photon carried by the electron, now it is used as the velocity to give the velocity to the electron which is emitted out. And with this velocity, the electron now possesses some kinetic energy, which is written as half mv square. Here we have put a subscript max, that means maximum kinetic energy. M is the mass of the photoelectron. So that the Einstein theory says about this photoelectric emission, that whenever energy is absorbed by one electron, the electron uses this energy in two steps. In first step, it overcomes or controls the we can say binding energy or work function of the metal, right? And the remaining part of this energy, it is used as the to give the kinetic energy to the electron. So according to law of conservation of energy, total energy will be same. So before, the total energy was h nu, and after it is now used in two ways. In first part, it is used to overcome the work function, and the remaining part becomes the kinetic energy of the electron. So therefore, total energy carried by each photon, it is given by work function of the metal surface plus the kinetic energy which is given to the electron. So we can write this work function. This is the minimum amount of energy. So we can write this as h nu naught to counter for the we can say existence of threshold frequency. We can write the work function to be h nu naught. This is the minimum amount of energy which a radiation or we can say photon should possess in order to cause the photoelectric emission. Kinetic energy may be zero, but this is the minimum amount of energy which this must possess, the radiation, incident radiation, or we can say photons of incident radiation must possess. So from here we can write the kinetic energy as it is h nu on the one side, and we take the h nu naught also to the other side. So therefore kinetic energy carried by a photoelectron is written as h nu minus nu naught. So this equation, it is called as the Einstein photoelectric equation. Einstein explained all the laws of photoelectric effect with the help of this equation, which is on the basis of the photon theory, or we can say particle theory of the light. So you can also have the observation of this diagram. Photon of radiation h nu is incident. There is some work function, or we can say minimum amount of energy which is used here, and the remaining energy becomes the kinetic energy of this electron. Okay, so let us try to understand the laws of photoelectric emission based on this Einstein's theory and Einstein's photoelectric equation. So Einstein's equation or photoelectric equation says half mv square means kinetic energy of the electron. It is given by h nu minus h nu naught, which is nothing but h into nu minus nu naught. This is just representation of this Einstein's equation. Okay. In the first point, it can be seen that if we nu, the frequency of the incident photon is less than the frequency which is required, means threshold frequency, then the value of this kinetic energy will be negative. If nu is less and nu naught is more, then that means simply the energy of the incident radiation is less than the energy required to carry out the photoelectric emission. So in that case, this kinetic energy of the electron will come out to be negative, which is something that does not exist. A negative energy has no existence. So therefore, for photoelectric emission, from the Einstein's photoelectric equation, it is clear that the for frequency less than the threshold frequency, this is called as minimum frequency, threshold frequency, below which there is no emission, right? Because energy comes out to be negative, which is an impossible case. Okay. Another thing is that since one photon emits one electron, this is because one photon is completely taken away by one electron only. So the number of photoelectrons emitted per second, it will be directly proportional to the intensity of the incident light, right? Because the intensity of the light means more intense light means more number of photons per second. A more intense light will carry more number of photons per second, because one photon is used by one electron. So therefore, more the number of photons per second means more is the intensity of the light, more will be the more number of photoelectrons will be emitted out. So it again explains that the photocurrent depends upon the intensity and not the frequency of the incident radiation. Another thing is that it is clear that this kinetic energy, it is directly proportional to the frequency of the incident radiation. Of course, higher and higher is the frequency of the incident radiation, more and more of its part will be left as the kinetic energy of the electron. So that means a higher frequency radiation can give more amount of kinetic energy to the electron. So kinetic energy depends upon the frequency. This shows that kinetic energy of the photoelectron is directly proportional to the frequency of the incident radiation. And also, last point is that photoelectric emission is due to the collision between a photon and an electron. As such, there cannot be any significant time lag, because it is just the case of a collision between a photon and a electron. Photon, which is taken as a particle according to the particle theory of the light of the Einstein. So therefore, there can be no time lag between the incidents of photon and the emission of photoelectrons. That is, the process is quite spontaneous. It has also been found that the time lag between the incidence of the photon and emission of photoelectron is just 10 to the power minus 8 seconds, which is very, very small. So the process is quite spontaneous. So therefore, here we see that the Einstein's photoelectric equation or photon theory of light or particle theory of the light correctly explains all the laws of the photoelectric effect. So that is all for now. Thank you.